So the last thing we were looking at is the power set of a set. Given a set A, the power set of A, it's, and this needs the set builder notation, the set of all B such that B is a subset of A. Okay? The set of all subsets of A. So, for example, here is the set containing elements 1, 2, 3, and 4, and its power set consists of, and think of these, so this set has order 4. So think of them as organized according to order of the subset. So a subset has order 0, 1, 2, 3, or 4. So subset of order 0 is the empty set. And subset of order 1 are these. Subsets of order 2 are these. Subsets of order 3. And then the only subset of order 4 is the whole thing. How about this example? I had an assignment on them. Make sure I don't do the problem I assigned you. Yeah. Okay. How about this? How about the power set of the set containing two elements, A and B? All right. What's the first subset? The subset of order 0.
The null set.
Mm-hmm. Next, subsets of order 1.
The set A and the set B.
And then the last one, subset of order 2. Going to be
AB.
Mm-hmm. All right. So, how many elements do we have in this set?
4.
4 elements in the set. Okay. So in the previous example, notice we have 4 elements in the set and then 16 elements in the power set. So notice the order of the power set of 1, 2, 3, 4 is equal to 2 to the 4th. All right, this is a set of order 4, and the power set has order 2 to the 4th. All right, this is a set of order 4. The order of the power, well, first of all, the order of the power set of AB is 4, which is 2 to the 2. So that's a set of order 2, and the power set has order 2 to the 2. And that's the case in general, and I'll explain that in a moment. But now, suppose I was to ask you the following. Well, let me give you a preliminary question. What's the difference between two sets of order 4? Well, the answer is everything and nothing. What do I mean by that? What is the difference between two sets of order 4?
the actual elements inside?
Mm-hmm. Yes. The actual elements inside. So let's take that a step further. Not just the actual elements inside. I mean, not as much as the actual elements inside, just the names of the elements. I mean, you could insist that a set of order 4 has elements named 1, 2, 3, 4. Like, the only set of order 4 in existence in the entire universe, both real and imagined, is this set here. Any other set of order 4 is just some set where these things are renamed. Right? 1 is called something else, 2 is called something else, 3 is called something else, 4 is called something else. Okay? So, in this here, okay, the 4 elements of the power set of AB are, and let's color them red. All right, so let's color those elements red just for illustration purposes. All right. So now that we've colored those elements red, tell me what the power set of AB is. Well, let's start with this here. How can I so these are 4 elements, right? You can call them elements 1, 2, 3, and 4. 1, 2, 2, 3, 4. Don't get hung up on what the names of the elements are. Don't get hung up on the fact that each element isn't a single character, isn't a single pen stroke. Okay, how can I write down? These are just 4 elements here. So I'm talking about the power set of a set of order 4. So from here, how do I get the power set of this set of order 4? What would I do?
I mean, you can just start with a null set. I mean, like, or you, or I mean,
what's
you
the
just,
name? What's the name of the red null set?
Oh, the red null set. It's
the red null set has a name. Name's 1.
Oh, yeah. So you could just replace every 1, 2, 3, and 4. In
every 1, 2, 3, and 4, give them a new name. Every 1, 2, 3, and 4, give them a new name. The new name of 1 is this thing. Don't call it null set. Just call it this thing. The name of 2 is that thing. The name of 3 is this other thing. And the name of 4 is the 4th thing. So this thing, that thing, the other thing, and the 4th thing. Okay, so let's rename. This one is still 2. Let's do the renaming. Okay, let's erase all the 1s and put the new name. What's the new name? Don't say empty set. What's the new name? too familiar. It's just this thing. How do I draw this thing? What goes here? What goes right here?
1.
Yeah, but I'm taking it away. I'm renaming it. So what do I put here in its place? This. Is the red thing the same as that, even though they're drawn the same?
No.
Nope. All right, let's do 2. Get them all. I'm gonna have to zoom in. Make them smaller. Well, that's fine. Those are fine. There's a comma missing in one of them somewhere. Here. 2, or we already did 2. 3 becomes what? Becomes this. Squiggle B squiggle. Or not B. Oh, shoot. It was supposed to be an A, not a 1. A, 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 A.
That second A in the
Oh,
top is supposed
that's
to
a
be.
B, yeah. All right, so that's B. No, this is A. This is B. 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 That was an A. B. B. And then 4, what's 4? 4 is the set containing what?
A and B.
Set containing A and B. I missed this one. That's the set containing B. So, I mean, being really just sort of very detailed about it, that's the explanation. Oh, this one right here as well. But what I would like to do is just write it out, okay, without all of this, talk about colors and stuff like that. I just want to erase it and just write out the whole thing. Okay, there are 4 elements in the set, power set of AB. There's 4 elements in this set right here. So now give me all the subsets of that set. One moment. How can I erase that faster? And let's just do it all in black. Okay, give me, for these 4 elements, this set of order 4, give me the subset of order 0.
Would just be the null set.
The null set. Okay. Now give me the 4 sets of order 1. 4 subsets
The
of order
set
1.
of the set of the null set.
The set with the null set. This is a set with 1 element in it. That element is this thing. Next set.
The set of A.
Ooh. This.
The set of B.
No. No. This is
And
not
the set
correct.
of AB.
This is incorrect.
That's incorrect? Why?
This one is incorrect. This is an element of the power set of AB. Now, give me a subset of the power set of AB that has this element in it. How do I write it? This is the element right here. Okay? This is the element. This is an element of this set. Now, give me the subset of this set that contains this element only. It's not this. That's incorrect.
Be the set of A.
Yeah, it gets nested twice. This is the element. So this element that's in the box right here goes in its own set, right there. Right, nested parentheses. Right, the parentheses have to be nested in the proper way for it to make sense. This is the element. Again, don't get hung up on what the element looks like. Just take that element and put it in its own set. Okay, suppose we have this element here. Here's an element. Put this element in its own set. Tell me the symbols I would write from left to right. Here's an element. Put this element in its own set. Tell me the symbols I would write from left to right. What's the first symbol?
A curly bracket.
Mm-hmm. Then
One.
the element. Then
A curly bracket.
sometimes called brace in some circles. All right, so fine. So this element that I boxed goes in between braces. Okay. Again, don't get hung up on what the element looks like. I could make the element look different. Same idea. Now, if I made the element look like this, why does it become confusing suddenly? Should it be confusing suddenly? This is the element right here. It goes inside its own set. I don't care if this symbol is the same as that symbol. Okay? I imagine most of you are math majors. Have you taken your computer programming course yet? I think, like, some computer programming course is required for the major CS Java programming or something.
I'm a double major in math and psych, so yeah, I have to take it.
Yeah, so I mean, when you're when you're doing programming, I mean, if you don't get your delimiters nested properly, the thing doesn't work, right? So this is something important to recognize. Okay, enough with that. So next element. So this is a subset of order 0. This is a subset of this set of order 0. Actually, every set has this subset of order 0. This, right, that's order 0. This thing has order 1. This one has order what's the order of this set here?
1.
1. All right, next set of order 1. Subset of order 1. Going to be what?
The set of B.
Then the fourth one is going to be what? Set with the set.
A comma B.
So again, this is a subset of order 1. This is a subset of order 1. They're all subsets of order 1. Okay, subsets of order 2. Subsets of order 2. Okay, give me the first two elements here.
Zero.
Empty set. Empty set. And then what? A. No, that's not right. Empty set and then what?
The set of the empty set?
Set of the empty set is not an element of this set. This is not an element of that set. There's 4 elements in this set here. They're right here. 1, 2, 3, 4. So subsets of order 2 would be elements 1 and 2, and then elements 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4. There's 6 of them. 6 subsets of order 2. So the first subset of order 2 would be elements 1 and 2. Okay, that's element 1. What's element 2?
Set of A.
It's set with A. Next. 1 and 3.
The null set or 0.
Didn't hear it. I'm sorry. It didn't come through. What'd you say?
Set of B.
The set with B. And null set 1 and 3, 1 and 4. It's going to be
Set of A and B.
So this set right here has 2 elements in it. This element and that element. Element 1 and element 4. So that's the third one. There's 6 of them. Next would be 2 and 3. So that's singleton A, singleton B. Sometimes those are called singletons. Let me see. Move this over. Just got more space. Singleton A, singleton C. And then singleton, or not C, I'm sorry, AB. And then singleton B, singleton AB. They're not giving me enough space. Tried to get everything lined up nicely, it just didn't work. Okay. Subsets of order 3. So elements 1, 2, and 3. So that's element 1, 2, and 3. Elements 1, 2, 4. Elements 1, 3, 4. And elements 2, 3, and 4. So 4 subsets of order 3, and then 1 subset of order 4, which is the entire set. Elements 1, 2, 3, 4. Okay? So in the homework, in the assignment for chapter 3, number 3 here, we got this set, capital A, is a set containing 3 elements, A, B, and C. Find the power set of A, and then find the set of all X in the power set of A, such that, or the power set of A, excuse me, such that the order of X is 2. So get started on that, and please get started on this assignment as soon as you can. Don't wait until the last minute. Okay. One last note about the power set. The order of the power set of A when A is finite. If A is finite, then the order of the power set of A is 2 to the order of A. Always. Why is that exactly? Why is that exactly? Why would the power set of A have order 2 to the A? So if we're going to create a subset of A, so we're going to create one subset of A, how do we do it? We go through all the elements of A and we say, put it in or leave it out. Put it in or leave it out. And you do that in all possible ways. Right? So for each element, you got 2 choices. Put it in the subset you're constructing or leave it out. So if I have, so if the order of A is n, if I have n elements, and I make 2 choices independently for each one of 2 choices independently for each element, then the number of ways that happens is 2 times 2 times 2 times 2 times 2, so on and so forth. You're just multiplying 2 by itself. Right, it's like if you're going to flip a coin once, how many outcomes? If you're going to flip a coin, heads or tails, how many possible outcomes are there? 2, right? If you're going to flip the coin, flip 2 coins. How many? 2 different coins, not the same coin. If you're going to flip 2 different coins, how many possible outcomes are there? 4, right? Coin 1 and coin 2. Heads, 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 tails, tails, heads, tails, tails. 3 coins, how many outcomes? 6. 6. 6. It's 8, yeah. Multiply, not add. Right? When you're making independent choices, and you want to know how many outcomes there are, you multiply, right? I mean, if, for example, if I have five pairs of socks and 2 pairs of shoes, how many ways can I put on socks and shoes? 7. Got 5 pairs of socks, 2 pairs of shoes. Yeah, everybody knows that. Yeah, that's something that we intuitively know, and we've been doing. This is the same idea. You just the number of choices is only 2. But you can generalize that, or if you're going to, if you ever been to, I'm sure you have, but I mean, like when you go to not a buffet, what do you call it? A banquet dinner, right? Like on the invitation says, well, do you want the chicken or the beef or the vegetarian dish, right? So you have 3 choices of dish. Do you want salad or soup to start with? So there's 2 choices of starter. And do you want, one of 5 different drinks, right? So there's 3 main courses, 2 starters, soup and salad, and like 5 different beverages. So the number of combinations you can get is the product, 3 times 2 times 5, right? So 30 possibilities. So same thing here. When you're doing the power set of a set, you're just asking for each element. You're going to put it in a subset or not going to leave it out. Okay, and if you're making a particular subset, does the element go in or does it get left out? So you make those choices 2 to the n number of ways. All right. Okay. Operations on sets. So various binary operations, integration, intersection. Given 2 sets, A and B, A intersection B is equal to the set of all elements X such that X is an element of A and X is an element of B. Right? Notice that intersection is defined using conjunction, and the symbol for intersection and conjunction is similar. So the Venn diagram for this looks like the following. I mean, if you had 2 sets, A and B, living inside some universal set. So here's set A, here's set B. The intersection is everything that's in both sets. I mean, these are all, people are making all kind of memes these days on Facebook with set intersections. So for example, zero, 1, 2, 3, 4, 5, intersection 1, 3, 5, 7, 9 is equal to what? Right, what's the intersection? It's the elements that are common to both. Think
1,
1,
3, and 5.
5, right. How about that then? Let's see. 2, 4, 6, 8, 10. 1, 3, 5, 7, 9. The intersection here is
0.
is the empty set, yeah. All right. If A is a subset of B, then A intersection B equals what?
A.
It's just A. Intuitively, it's A. Okay, why exactly it's A? We'll talk about that, as we go along here. Next operation, union. Given two sets A and B, A union B is the set of all elements X such that X is in A or X is in B. So notice it's defined using OR, and it uses a symbol very close to OR, to the symbol for OR. The Venn diagram for the union of two sets. So I mean, if this represents the elements of A and this the elements of B, then the union is just everything that's in one or the other set. So the elements over here, the elements over here, and the stuff in between. So everything that's in one set, the other, or both. So for example, um, 0, 1, 2, 3, 4, 5. Union 1, 3, 5, 7, 9. That's going to be the set containing what elements?
Zero, 1, 2, 3, 4, 5, 9.
5, 7, 9. Yeah. If A is a subset of B, then A union B is going to be equal to what?
Would it be equal to B?
It's just going to be equal to B. How about this? The order of A union B is equal to what? Well, let me start out a little bit. The order of A, so the order of A, that's all the elements that are within the circle for A, plus the order of B, so that's all the elements within the circle for B. So that would be the order of A union B, except I've done what? I've double counted what?
What they have in common,
What
so
they
you
have
have to subtract it all.
Right, precisely. Yep. Minus the order of the elements in A intersection B, right? Because this counts every element in A once. This counts every element in B once. So together, the elements in A intersection B were counted twice. The elements that are in A or in B, but not both, were counted once. So we want to get rid of the double counting because this is only counting those elements once. So we subtract off the order of the intersection. All right. Set subtraction. or set difference. Given two sets A and B, A minus B is equal to the set of all x such that x is an element of A and x is not an element of B. All right, and this is sometimes written as A backslash B rather than A minus B. Sometimes it's written like that to differentiate between like ordinary subtraction and this idea here. So the Venn diagram for that looks like the following. So it's the things of A that are not in B. So that's this part of A. That's A minus the stuff in A intersection B. The stuff that's in B but not in A doesn't really figure into it. So, for example, For example, uh, 0, 1, 2, 3, 4, 5 minus 1, 3, 5, 7, 9. That's going to be equal to what? It's the stuff that's in A but not in B. So what am I taking away from A? These are odd integers from 1 to 9. So here I'm taking 1, 3, and 5.
1, 3, and 5.
Yeah, so I'm just left with the even, or not empty set. I'm just left with these even guys. This is the same as right? The stuff that you're taking out of A is the stuff within the intersection of A with B. Right? The stuff that's in the B but not with the A, that doesn't enter into the discussion and it doesn't have any effect. Right? Like the fact that 7 and 9 are listed here doesn't affect the outcome, and not listed here doesn't affect the outcome. In general, A minus B is equal to A minus A intersection B. Okay? Symmetric difference of two sets is closely related to that. Yeah. If you were to take a class in, they start doing some probability type stuff, and they need to talk about sets, because all these things like Bayes law and Bernoulli trials, they're all stated in terms of sets. We do have some overlap between the courses with these basic concepts. If you are a computer science major, you'll take Math 2570 or Math 2200, excuse me, or Math or Computer Science 2200, and that would contain this stuff as well. So given two sets A and B, the symmetric difference, a triangle B like this, is equal to, well, it's A minus B union B minus A. This is equal to A union B minus, I'll use parentheses, minus A intersection B. So for the Venn diagram, oops, that looks like the following.
For the part where you have A union B minus, is that supposed to be A something B? 'Cause
Oh,
there's nothing
union,
there.
I'm sorry, yeah. Yeah, union.
And then on the other side of the equations, there's something missing between A and B, I think.
Oh, right. Intersection. A union B minus A intersection B. So it's the stuff that's not common to, it's the stuff that's in one set or the other, either in A or in B, but not both. So the exclusive OR, as it's often called. All right, so it's 1:15 at this point, so this is going a little slower than I would have hoped. I am going to post the remainder of the lecture on Chapter 3, probably on YouTube. So keep an eye out for that. I will send a message, when that lecture is up. So next time, we'll talk a little bit more about the assignment for Chapter 3, any last minute questions on Chapter 2, and then see where we can go from there, okay? All right, everybody, have a good afternoon, and we'll see you on Friday. And you can email me if you have any concerns as well.